We just kick its little legs and it'd be fine. It's a sea bear. Okay. Let's start with the ellipse, and we'll go back to 11.2. Let's just review real quick how to graph an ellipse that's not been shifted, and then we'll take a look at one that has been shifted. Ellipse. Yeah. So, quick review. Let's consider this problem here. How would we graph x squared over 4 plus y squared over 9 is equal to 1? First thing you really ought to consider is this a vertical ellipse or is it a horizontal ellipse? It is vertical. The way that we tell with the ellipses is we locate the larger of the denominators. 9 obviously is larger than 4. 9 is underneath the y variable. That means this has been elongated on the y-axis. It's a vertical ellipse. That makes this a squared. If a squared is equal to 9, then a is equal to plus or minus 3. B squared is equal to 4, so b is plus or minus 2. Is this coming back to you? Yeah. Since this is a vertical ellipse, the a values go on the y-axis. So we're going to place 3 and negative 3 on the y-axis. 2 and negative 2 go on the x-axis. Sorry, I know I'm going pretty fast here, but I'll make sure that we have time for everything today. So there's your ellipse. Ooh, that was not good. Make sure yours looks better than mine. Matter of fact, I'm doing this. I'm cheating.
No, it's not fair.
I can pretty much do whatever I want, so. Ooh. Almost perfect. Well, you get the idea. There's your ellipse. Oh, we're forgetting something though. Dang it. The foci. No graph is complete without its foci. What are you guys, crazy? It is incomplete. It's missing the foci. The foci formula for ellipses is a squared minus b squared. So this turns into c squared equals 9 minus 4, which is 5. So c is plus or minus square root of 5, which is slightly larger than 2. So on your y-axis, you place your foci just above positive 2 and just below negative 2, and label them. Focus 1, focus 2.
Are we supposed to know what the square root of 5 or the square root of 6 or whatever is to put it out?
Well, you can estimate.
It might be hard to find like the square root of 13 if you did that.
A little bit smaller than 4.
But are we supposed to know?
Yes. Because you know the square root of 16 is 4, so square root of 13 just slightly lower than that. We're trying to get out of stuff. So what we're looking at now would be something along these lines. Okay, here's a shifted ellipse. It's of this form, x minus h squared over a squared plus y minus k squared over b squared equals 1. This is an ellipse that's no longer centered around the origin. The center, you guys are probably clever enough to tell me, just how the equation looks, where would you guess the center is? H comma k, exactly. Inside the x part is a shift horizontally in the h, okay? Inside the y part is a vertical shift by a factor of k, so the center is h comma k. Absolutely right. So let's take a look at an actual example. Graph parenthesis x plus 2 squared over 16, and then in parenthesis y plus 1 squared over 9.
So listen really carefully, because
one part here I think is at least a little bit different than what you might be thinking. What's that phrase I had you repeat a couple of times during the quiz? Inside the function is opposite. There's two functions we need to consider here, okay? X minus 2 squared is a function. Y plus 1 squared is another function, okay? X minus 2 to the second power, I think we're pretty sure on what direction that's moving. What direction? To the right. Okay, it moves it to the right 2 units. What about this one? It moves it down. This is inside of a function, even though it's with y. Okay, y plus 1 to the second power is considered inside of a function, so this is moving down 1 unit. Okay, so the center now, let's draw a graph. The center of this ellipse has been shifted to the right 2 units and down 1 unit. So place a point right there to the right 2 and down 1. Now, I'm going to make a suggestion. I don't know if necessarily if your book makes the same suggestion, but this is what I'm going to make. Draw a new coordinate system centered around that point that you just made. So make a vertical line and a horizontal line going through that new point. Okay. Here's what I want you to think of. Rather than shifting the actual conic, or the ellipse in this case, we're shifting the origin. We're shifting the entire graph. Okay. We're considering this now to be our new origin, and we can graph this ellipse just like normal in regards to this new origin. So what kind of ellipse are we graphing here? Vertical or horizontal? Horizontal. That makes this a squared. So a is equal to plus or minus 4. B squared is equal to 9. That means b is equal to plus or minus 3. So if we go back to this shifted origin, we can place plus or minus 4 on this new x-axis. So we're going to now keep the scale the same, the distance between tick marks. So we're going to go over 4 to the right and 4 to the left on the new x-axis that we've shifted. And we're going to go up 3 and down 3, again trying to keep the same scale. And there's an ellipse. It's been shifted to the right 2, down 1. Still need the 2 foci. So c squared is equal to a squared, which is 16, minus b squared, which is 9. 16 minus 9 is 7. So c is equal to plus or minus square root of 7. Which approximately is what? Between 2 and 3, possibly closer to 3. On which axes? Which one? The x1 or the y1? Okay. This new x-axis. So we're going to go in between 2 and 3, slightly closer to 3 than we are to 2, and then in the other direction. Yeah? No. Now here's what we really got to think now. What is the actual location of these points? Okay, the vertices in particular and the foci. This point here, the b values really that important. But if I asked you for the actual location now of that vertex right there, that's not in regards to the origin that we shifted. That's in regards to the original origin. So what is the actual location of that point? 6, -1. Okay, and the actual location of that point is -2, -1. So on your assignment, if they're asking for the location of the vertices and the foci, they're meaning in regards to the original origin, not the one that we've shifted. All right, think carefully. What's the location of that focus?
Square root of 7, -1. And then the other side would be
Close.
Oh, wait.
Well, can we agree on the y part of this focus? Isn't that -1?
Yes.
We can agree on that? Okay. Now, answer this question. From the new origin over to the focus, what is that distance? That's the square root of 7, right? But what's the distance from the x or from the y-axis over to there? That's 2. So the combined distance from the axis all the way over there is 2 plus the square root of 7. So that focus has a location of 2 plus the square root of 7. Now the other one also has a y location of -1 because it's been moved down 1. But what is the x location here? Yeah, those are both good arguments. Answer this question first of all. Since it's on the left side of the y-axis, it's going to have a negative value, right? Answer this other question. What's larger, 2 or the square root of 7? Square root of 7 is larger. So if we said it's the square root of 7 minus 2, would that have a positive or a negative value? That would have a positive value, but this focus is on the left side of the y-axis. So it can't be square root of 7 minus 2. That would give us a positive. Does that make sense? So 2 minus the square root of 7, would that give us a positive or negative value? That would give us a negative value. So it's 2 minus square root of
negative square root of 7 plus 2 all 4.
That would work. Yep. Wait, you said negative square root of 7 plus 2? Yeah, that'll work. Okay. Let's talk about hyperbolas. And I know that's not how you say it. So hyperbola. Not to be confused with hyperbole. Have you guys learned about that in your English classes yet? A hyperbole that's like an extended metaphor, isn't it? I can't remember. Exaggerate.
In writing.
Like, you guys are so awesome, I love you so much. That'd be a hyperbole?
Utah is awesome.
That's
That would
sarcastic.
be a hyperbole.
Anyway,
No, that's just a lie.
that's 2 minus the square root of 7. Yep. Let's do a quick review of how to graph just a normal hyperbola, and then we'll take a look at a shifted hyperbola. So, y squared over 16 minus x squared over 25 equals 1. This hyperbola is still centered around the origin. And it is vertical because the y variable is positive. Okay? And you have to remember the differences between hyperbolas and ellipses. First of all, the minus sign is a big difference. And second of all, it doesn't matter which denominator is larger. Okay? The one underneath the positive variable is always a squared. So this 16 is a squared. Even though it's smaller, it's underneath the positive variable. So that means a is plus or minus 4, and b is plus or minus 5. The process for shifting a hyperbola is much different than graphing an ellipse. This one includes that central box with the slanted asymptotes. Your a values go on the y-axis because this is a vertical hyperbola. Those are your vertices. The b values go on the x-axis.
Now what?
Box. Good. Okay. After the central box is drawn, you graph in your asymptotes. And then, since it's a vertical hyperbola, the pieces of the hyperbola fit in the top and the bottom section. And don't forget about the foci. Another big difference is the foci formula. It's c squared equals a squared plus b squared. So we have 16 plus 25. Oh man. C squared is 41. So c is my square root of 41. Again, just estimate. It's larger than the square root of 36. We know it's greater than 6, but it's smaller than the square root of 49, so it's not greater than 7. It's in between 6 and 7. Pretty much right smack dab in the middle. So between positive 6 and positive 7, between negative 6 and negative 7, those are the two foci. Now, this one's going to seem a bit strange. Keep an open mind.
Wow. Wow.
Oh, that makes perfect sense.
I'm just kidding. That last part's a joke.
Oh,
It equals 16. Told you to keep an open mind.
yes, and then when I did, you added all of the square roots and pi and
Um,
I saw this the pie and I just said, where's the circle?
yeah. So, is this... What is this? Messed up? It's obviously not in the form we need, correct? This is called general form. Of a conic. In general form, is it easy to tell what type of conic this is? No, not really. Okay, this could be an ellipse. It could be a hyperbola. We know for sure it's not a parabola. How do we know that for sure? It has x squared and y squared. So we know it's not a parabola. It's either an ellipse or a Hyperbola. Let's go back to chapter 3. Way back to chapter 3. If you think you need to write this down, you can. If not, just pay attention real quick. This is the general form of a quadratic. This is a quadratic in general form. Do you remember the process we needed to use to write it in standard form? I remember. It's complete the square. Who said
Complete the
that?
square.
I said it.
Oh, I was sure you guys remember.
What about the negative b over 2a?
That works for parabolas, but it doesn't work for what we're about to do.
Darn it.
Okay? Let's run through this process real quick. How do we complete the square? Subtract the 1. Factor out the 2. Okay, and now we have a blank spot inside the parenthesis that we need to complete the square. Divide b in half and square it. So it's going to be? But we really didn't add a 9 here. We added 9 times 2, which is 18, so we have to add 18 here. So now we have y plus 17 equals 2 times parenthesis x plus 3 squared. Subtract the 17. And this is the resulting quadratic in standard form, or vertex form. Remember this? What you guys are going to have the pleasure of doing is completing the square once on the x variables and completing the square again on the y variables. Okay? We have to complete the square twice. Okay? Once with x, once with y. Okay? Matter of fact, let's write this down. General form of a conic. Okay? Complete the square on x and y. Don't look so excited about it. I can't take your enthusiasm. You're too energetic.
Sorry.
You guys need to calm down for the love.
I just can't contain my excitement.
I know. So let's consider just the x variables. Okay? The x squared has a coefficient, so that needs to be factored out. If you factor out the 9 from 72, what are you left with? Negative 8x. Remember to close your parenthesis in such a way that you leave room to complete the square. Okay? Now what value completes the square? 16. It's half of b, which is negative 4, and then you square it. So it is going to be a plus 16 inside the parenthesis, but again, really, it's not a plus 16 that was added here. We have to consider the 9 as well. 9 times 16 is 144, so to balance the equation, we have to add 144 to that side to keep the equation balanced. Okay? Now we have to complete the square on the y variable. The y variable also has a leading coefficient of negative 16. Okay? Actually, we do this in a different color. So if we consider the variables with y, you factor out the negative 16. That leaves you with y squared plus 2y. Close the parentheses in such a way that you can complete the square. What value completes the square? A plus 1. But it's not really a plus 1 that we added. It's a negative 16, so we have to add a negative 16 to the right side to balance us out. And nice for us, the 16 and the negative 16 cancel. So on the right side, all we have is 144.
Okay. That makes our life so
Okay?
much simpler.
It does. And then with the x's, we still have that 9 as a leading coefficient. But the x squared minus 8x plus 16 factors into x minus 4 squared. For the y variables, we have that negative 16 as a leading coefficient, but the y's factor into y plus 1 squared. Is this looking better now? Okay. Divide by 144, because in standard form of a conic, it equals 1. So divide everything by 144. And now we have equals 1 on the right side. We're getting somewhere.
Yay.
9 divided by 144. I'm taking a look at these values right here. 9 divided by 144 is x minus 4 squared over 16 minus, and then if we consider that fraction, 16 over 144, that's just 1 over 9. So this is y plus 1 quantity squared all over 9. And ta-da! Now what type of conic is it?
Oh.
It's a hyperbola. Shifted where?
Positive 4.
To the right 4
And down one.
and down 1. It's going to the right 4, down 1. Alright, so we're ready to graph, finally, after months of agony. I'm going to make the same suggestion here. Shift the origin. Okay? Go to the right 4 units, down 1 unit, place a point there, and then draw a new axis system. Okay? If a squared is 16, then a is plus or minus 4. This is b squared, so that means b is plus or minus 3. B squared is 9, so B equals plus or minus 3. We've got to be clear on which axes we're placing. What type of hyperbola is this? This is the positive term, right? The x minus 4 is the positive term. It's the x term that's positive, so it's a horizontal hyperbola. That means the a values go on our new x-axis here, and the b values go on the new y-axis. So on the new x-axis, you're going to go out 4 in each direction from the new origin, keeping the same scale. So go over to the left 4, and to the right 4, and then up 3, and down 3. Draw the central box. Yeah. Using the central box, draw your slanted asymptotes through the corner and the center. Okay, and since this is a horizontal hyperbola, it's going to be in the right side and the left side of these asymptotes. And we need the foci. C squared is equal to a squared plus b squared. 16 plus 9 is 25. Oh, this works out fantastic. So C is plus or minus 5. Remember, that's in regard to our new coordinate system. So starting from the new origin, go over 5. That's one of the foci. Go to the left 5. And there's the other focus. Okay. For lack of time, we just don't have time to describe the locations of those, but in your homework, it is going to ask for the location of the foci and the vertices. Please remember they're talking about the location in regards to the original origin, not the shifted origin. Okay? Oh, parabolas. Or as they say in England, parabolas. I don't know if they say it there. So let's just do a quick review of how to graph a parabola that's not shifted. So if we have the equation x squared equals 4y. Remember, this is different than considering the parabola as a function. We're considering the parabola now as a conic. If we were studying this back in Chapter 3 and Chapter 4, your tendency would have been to get y by itself, and that's correct, if we're studying it as a function. As a conic, we don't want to get the non-squared variable by itself. We want to get the squared variable by itself. So this is the form we actually wanted. X squared equals 4y. Okay. Now, what type of parabola? This one's vertical. Okay. X squared is vertical. Y squared is horizontal. So, if we compare this to the general form of a parabola, x squared is equal to 4 times p times y. So we need to consider the coefficient of the equation we have
1.
and the coefficient of the general equation there. That means that 4 is equal to 4p, so p equals 1. What's the significance of the value of p? The focus. The focus. Remember, if there isn't any shifts, the vertex is at the origin. So this is the focus. The focus is 0, 1, because that places it on the y-axis. And then the directrix is the equation y equals -1. That's a horizontal line. So the focus is here at 0, 1. The vertex is 0, 0. And the directrix is this horizontal line. Now, graphing this was much different than how we graphed a parabola back in Chapter 3. Rather than just graphing points and plotting points, we had to use the latus rectum and the focal diameter. Okay, the focal diameter is the absolute value of 4p. But if p is 1, 1 times 4 is 4. So it's a length of 4. What that means is the latus rectum has a length of 4 units. The latus rectum goes through the focus. Okay? And it's the same distance on either side of the focus. So if the total length is 4, what's the length on either side of the focus? 2. Okay? So there's one endpoint of the latus rectum. Here's another endpoint of the latus rectum. The endpoints of the latus rectum are on the parabola. That's why we graph it, because it gives us 2 other points. So now you have the vertex and the 2 other points you need to graph. That's how we graphed parabolas. Here's one that's shifted. And holy smokes, we gotta move. Let's consider x squared minus 4x equals 8y minus 28. We have to complete the square on x only on x, because there isn't a y squared variable, so we can't complete the square, because y is not a quadratic. X is a quadratic. So if we complete the square on x, there is no leading coefficient of x squared, so we don't have to worry about factoring anything out. So we can just write x squared minus 4x, but then we have to complete that blank spot equals 8y minus 28. So what number completes the square to make it into a perfect square trinomial? It is going to be 4.
I need Daisy Albert to the front office.
Okay,
Thank you.
you're welcome.
You're the only teacher I know that says you're welcome.
just pull out. But if we add 4 here, we have to keep the equation balanced and add 4 there. The left side factors into x minus 2 quantity squared. What do we get on the right side? Okay, we do
8 times y minus 3.
We do get 8y minus 24, but Joe, you're absolutely right. We have to factor out that 8 and write it as 8 times quantity y minus 3, because we have to have shifts in both the horizontal and the vertical direction. That means that the x variables need to be in parentheses and the y variables need to be in parentheses in order to get the transformation. So what direction are we shifting horizontally? Horizontally means with the x variable.
Right.
To the right 2 units. Okay, and we're going up 3, because y minus 3 technically is still in a function, so it's going to be opposite. It moves to the right 2 and up 3. Ooh, tougher question here.
What significance does that 8 have?
That's what I was just going to ask. You're reading my mind. That's good. Well, actually, I was going to ask another question. What type of parabola is this? Vertical or horizontal?
Vertical.
How do we know it's vertical? X squared. Okay. Second question is what Joe was asking. What's the significance of the 8? If there were no transformations at all, if the minus 2 and minus 3 weren't there, then all we would have is x squared equals 8y. Right? So the 8 has the same significance as this 8 would. You compare it to 4p. 8 is equal to 4p, therefore p equals 2. Go to the right 2, up 3, plot a point there, shift the whole entire axis system, so make a new x and y axis. So that means the focus is going to be up 2 units from our new origin. So there's the new origin. Okay. The new focus rather, the new origin is our vertex. How do we get 2 other points on the graph? Yeah, we need the focal diameter. It's the absolute value of 4 times p, but if p is equal to 2, 2 times 4 is 8, absolute value of 8 is 8. So the whole entire length of the lattice rectum is 8. That means on either side of the focus, how far is it? 4. So it's 4 units on either side of the focus. So that the entire length of that segment is now 8. So those are some endpoints there. And there's the parabola shifted to the right 2 and up 3. Just in the nick of time.
No, you didn't
The
forget.
directrix, you guys forgot it. What's wrong with you guys? Where is the directrix?
Minus 2 or 1 actually now.
It's 2 units down from the new,
Which is what?
which is 1 unit up from the x-axis. So there's the directrix. I shouldn't have to remind you guys about that. Thanks.